Let's learn about the switch statement, which is an alternative way of writing a complicated if-else statement when all we want to do is to compare one value to multiple different options, basically. So in this example, let's say we have a weekday variable, and for each day there is a different activity. So basically we're going to map one activity to each day. So let's say day, and I'm setting it here to Monday. Now, maybe you're wondering why I'm basically hard coding all these variables and how this would work in the real world. Well, in a real application that's used by users in the browser, usually most of the data comes from user input. And so then we wouldn't be hard coding all of this stuff. Okay? But right now, well, we are just learning how to code. And so it's absolutely no problem at all to just hard code all of these values here. Okay? Now, anyway, going back to our example here, let's now essentially map one activity to each day. So Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. And for that, we could use an if-else statement with multiple else-if blocks, but we can also use the easier-to-use switch statement. So let me just write how that works, and then I'm going to explain it in a bit more detail. So what we're switching is basically the day. So this is what we're going to compare to multiple options. Then we need the curly braces to define a block, and then we can define cases. So let's say case Monday. Then this colon, and notice how it's a colon and not a semicolon like this. Then another indentation, and then here comes the code that we want to do. So as always, we log something to the console. And once more, in a real-world app, we will of course not be logging stuff to the console all the time. This is once more just so that we can learn how all this different stuff works. So let's say on Monday I plan my course structure. And here we can actually execute multiple lines of code. And we don't need curly braces for that. So after the case and the colon, all the lines are then executed. Okay, and the syntax of this switch statement is actually a little bit unusual. So it's unlike anything else in JavaScript, but well, that's just how it is implemented, I guess. So anyway, we will execute two console.logs here. So the second one is go to coding meetup. Okay, so basically what this will do is it will compare day to Monday here in a strict equality way. So this here is basically writing day equal Monday. And if this is true, then this code here will be executed. Okay? Now, after this, we actually need this break statement. And you will see why in a second. And now let's add the next case here. So case Tuesday. So basically we're going to do one for each day of the week here. So let's say prepare theory videos and then another break. And I wish that preparing theory videos would only take one day, but it doesn't. Okay, so Wednesday is the next one. And actually we can do a nice little trick, which is to run the same code for two different values. So all we have to do is specify this case, and then we can specify another case right after it. So let's say Thursday here. And so whatever we write here will then be executed for both Wednesday and Thursday. So without needing any logical operators as we would need with an if-else statement. And actually we're going to translate this into an if-else statement after we're done here so that we can analyze the difference. So let's say Wednesday and Thursday I write code examples. On Friday I record videos And here's a small bug. So it's a colon, as I was saying you. And then let's do Saturday. And also the same for Sunday. So console.log, and then here, enjoy the weekend. Okay. And then, oh, I actually am forgetting the breaks here. So break. And I will show you in a second what happens without the break. But anyway, to finish, we can also set a default. And so the default is going to be executed if all the other cases fail. So default, just like this. And then here we can simply say console.log, not a valid day. So basically we're using this for an invalid weekdays. It's basically like an else block at the end of a long if-else statement. Okay, so let's now check out the result. And indeed, we get these two logs here from here. So from line 379 and 380, which are exactly these two lines of code. Then if I change it to, let's say, Wednesday, like that, we get write code example. And on Thursday, it should yield the same result because, yeah, we did this here for these 2 days. Now I guess I wrote something wrong. And actually it's here, Thursday, right? But so you saw that actually, since this option here was nowhere to be found, we actually got to the default block, which is then not a valid day. But now we should get the right code examples. Now without the break here, and let me comment it out just for demonstration. If we put this back to Monday, then let's see what happens if we load. And so now we get 3 outputs. We get this one, and this one, and this one. So that's the one immediately after Tuesday. And this happens because without the break, the code simply continues executing. And it stops here because here we have the break. But if I remove this break as well, then it would continue down this structure. And so after each block here, we need to tell it to stop, essentially. And so now it's fixed and it works just fine. Okay, great. That's how the switch statement works. And remember that this actually does a strict comparison. So it does it like this. Here it does, if the day is equal to Monday, then execute this. If the day is equal to Tuesday, execute this, and so on and so forth. So this was really designed for equality and not for like comparing stuff. It is technically possible to do that with some workarounds, but that's not the goal of the switch statement. Now, just as a fun exercise and to get a better idea of how this actually works and also how the if-else statement works, I want to challenge you to write this same logic, but this time as an if-else statement. Okay? And to do that, you will have to use a logical operator to translate the case of the Wednesday and Thursday case. So think about what happens. So basically, write code examples should be executed if the day is Wednesday or Thursday, right? So whenever the day is one of these two. So it's impossible to be Wednesday and Thursday because, well, 2 days cannot occur at the same time. So keep that in mind and yeah, pause the video here and really try to do this one on your own. Okay, did you do it? Well, let me just quickly show you how it's done. So remember that we're using strict comparison, so the triple equals. So if it's Monday, then do this, and I will, after finishing the structure, I will just go ahead and copy the console logs from up there. Then we need an else if. For the case it's Tuesday, then we need another else if in case the day is Wednesday, or if the day is Thursday. And again the same error. And you see that we're writing quite a lot of repetitive code, especially always the day and then the triple equals. So, and that's what the switch statement kind of tries to avoid. So else if, and then if the day is equal to Friday, do this. Else if the day is equal to Saturday, or the day is equal to Sunday. And finally, also the else block in case that we have an invalid day. So let's grab these here. And note that in this case, we of course don't need the break, because JavaScript will only execute one of these blocks. So Friday and now Tuesday, and finally Monday, these two activities. Okay, give it a save, and now I'm going to reload here. And so now we should expect the same result here, but twice. Once coming from the switch statement, and once from this big if-else block. Yeah, and indeed, it works just the same. Let's just try another one. Say Friday, just to make sure. And yeah, the result is the same. And so this logic here does basically exactly the same as this. We simply wrote it with a different syntax. Okay? So with the switch statement, we have to write a little bit more code, but in my opinion, it's also a lot more readable, which means that this one is easier to understand if you just read the code. Here we have a lot of this repetitive code and all these curly braces, and it just looks a little bit weirder. At least that's my opinion, but of course everyone is different. Now the switch statement is actually becoming less and less used, but you should still know about it, because there is definitely still a place for it sometimes. And actually in this example, for instance, I would actually prefer to use the switch. Okay, but again, that's down to your personal preference, and it's good that you start basically developing your own coding style into what you like the most. Now that we're getting more comfortable with JavaScript, it's time to learn about a more theoretical concept. And that's the difference between statements and expressions. And this is going to be just a very high-level overview, just so that the future lectures make more sense. So essentially, an expression is a piece of code that produces a value. For example, 3 plus 4 is an expression, because this is going to produce a value. Okay? So I don't even mean the entire line of code. What I mean is really just this 3 plus 4. This is an expression. Okay? And again, because it does produce a value. The same goes, for example, for just any number. This, for example, is an expression too, even though it's just a simple value. But it's still also an expression, because again, this itself will produce a value in JavaScript. Or we can do this. So true and false and not false. So all of this here is an expression, right? Because this will in the end produce some Boolean value. Now, on the other hand, we have statements. And a statement is like a bigger piece of code that is executed and which does not produce a value on itself. And we can compare this with normal spoken language. And so in this example, a declaration is like a complete sentence, and expressions are like the words that make up the sentences. Now, basically, we write our whole programs as a sequence of actions. And these actions are statements. So let's take as an example the if-else statement. So let's say if 23 is greater than 10, then, well, just do something. So create a string called 23 is bigger. The code itself doesn't really matter here. So this if-else statement is in fact a statement. And so that's the reason why I have called it the if-else statement all the time. And the same is true for the switch statement. So this statement here doesn't really produce a value, does it? All it does is, in this case, it simply declares this variable called str. But that's it. It performs some actions, in this case declaring this variable, but it doesn't produce a value. And so in that, it's different from, for example, having this here. Okay? Now the string itself, again, is an expression. So this is probably a bit confusing, but that's not a problem, okay? My goal here is not that you understand the exact rules of what an expression is and what a statement is, because in fact, it's all a bit fuzzy. So my main goal with this lecture is really that you know that statements and expressions exist, and that expressions produce values, and that statements are like full sentences that translate our actions. So the actions that we want the program to perform, okay? So really, that's all you need to know and all you need to basically memorize from this video. We don't need to go into all the details. So there's no need to start asking a bunch of questions about this in the Q&A section, all right? So this will all make even more sense as we move on. So I said that this string here is itself an expression, and then this whole line of code is a statement, because this again does not produce a value. And so basically, whenever something ends with a semicolon, that's then a statement. It's like a complete sentence, okay? Now this difference between expressions and statements is important to know because JavaScript expects statements and expressions in different places. For example, in a template literal, we can only insert expressions, but not statements. So let me just very quickly demonstrate that to you. So we can say, I'm, and then our placeholder here, basically. And so in here, we need to put an expression. So something that produces a value, which can then be put into the string that we're building here using the template literal. So let's say, just to do some calculations here, so 2037 minus 1991 years old. So again, this is an expression here. And so this one will work. However, we cannot do this. For example, we could not insert this if statement in here. That wouldn't make any sense at all. Okay, let's try that. And so we actually get right away unexpected token if. And that's because JavaScript knows that this is a statement and statements don't make sense where JavaScript expects an expression. Now, if we had a variable, for example, then if we used that here, then this would actually also be an expression, because this variable will essentially just be replaced with this string. And so this produces a value, and so of course, this is completely acceptable. Okay? And that's actually all I had to show you in this video. Again, my goal was really just to make sure that you kind of understand the difference between expressions and declarations so that moving forward, we are really both on the same page here. So we already saw two ways of writing conditionals: the regular if-else statement and the switch statement. But there is another one, and that's the conditional operator. And this one is actually really nice. So let's check it out. So the conditional operator allows us to write something similar to an if-else statement, but all in one line. So let's again start by defining an age variable, and this time I'm setting it to 23. And now let's write age greater or equal 18. So this is here our test to check whether the age is at least 18. So basically if the person is of full age. And then after this condition, we use the question mark. And then here we write essentially our if block. So that's the code that we want to be executed in case that this condition here is true. So let's say console.log, I like to drink wine. Let's again add a nice emoji here. So basically, if the person is of full age, they are allowed to drink wine, okay? And in this if block, so to say, we can only really have essentially one line of code. So only one thing can be done if this condition is true. Then we also need basically a mandatory else block. And that goes after this colon. And so let's just copy this code and say, I like to drink water. Okay, and that's actually it. So let's check the result and then analyze this a bit more. So in fact, what gets logged to the console is, I like to drink wine. And that's because the age is 23, and so this condition is true, right? And this means that this code here is going to be executed and this one is not. So the second part here, which is essentially the else part. Now, if we were 15, then of course, the second part is executed. Okay, so that's essentially writing an if-else statement all in one line. But instead of using a statement, we use this conditional operator. And the conditional operator is also called the ternary operator because it has three parts, unlike other operators. For example, the plus operator has only two parts. For example, 1 plus 2. But this one has three parts. So the condition, then the if part, and then the else part. Okay? Now, the conditional operator is, in fact, an operator, just as the name says. And remember that an operator always produces a value. So, in other words, an operator is an expression, right? So, what this means is that if we have a value, we can then assign that value to a variable. And so with this, we can make the ternary operator really useful to basically conditionally declare variables. So what we did here is not so much used, indeed. Instead, we do it more like this. So we would still test for this condition, let's say. So checking if the person is of full age. And if that's true, then all we want is essentially to return this. And if not, we only want this. Okay? And so again, this whole operator here is now an expression. And an expression produces a value. And so now we can go ahead and store that value into a variable. So let's call that drink. And then we can log this drink to the console. And let's comment out this part here and check. And indeed, we get wine as we declared up here. Great. So drink is now really defined conditionally based on this condition and all in one simple line. So without the conditional operator, we would have to use an if-else statement. And with that, this wouldn't be so easy. Remember, when we want to declare a variable inside of an if or an else block, we need to first declare that variable outside. So let's actually do that. So simply call it drink2. And then we would say, if the age is at least 18, then drink2 is going to be wine. Let's just grab that here. Or else, drink2 is going to be this water here. Okay, and again, we need to define the drink2 variable outside of the if and the else blocks, because any variable that we define inside of a block is not available outside. So we declare the variable here and then reassign it inside of the blocks. So just to make sure it worked, let's log this one here as well. But we really just did this for the sake of comparison. Okay, just so you can see the tremendous difference that the ternary operator introduces here in our code. So if you ask me, this one here is a lot easier to understand and a lot easier to write, right? So just changing this to something else here. And yeah, in both cases, we get a water back. So using the ternary operator, we were really able to transform this big block of code all into one small operation like this. And this is going to be useful in so many cases. And we will really take advantage of this throughout the rest of the entire course. And now we can take it even further. Because since the ternary operator is really an expression, we can now use it, for example, in a template literal. So unlike a normal if-else statement, like we tried and failed in the last lecture, remember? So that was here, where I tried to insert this if statement here, and of course it didn't work. But using the ternary operator, which produces a value, we can actually have conditionals inside of a template literal. So let's simply try that. And so I can now say, I like to drink, and then based on the age, I can say if I like to drink wine or water. So here in this placeholder, remember, I can put any expression that I want. And this here is an expression, again, because it produces a value. So I grab it from here, paste it here, and that's it. The template literal will now use whatever result we get from this operator. So that's either going to be wine or water, and then it assembles that result into the final string. So let's check. And indeed, once more, the conditional operator works just fine. And with our age back to 23, then we get, I like to drink wine. Great. So I hope that this makes sense. I know that especially this part here can be a little bit confusing for beginners. So take a minute to really understand what happens here. And always keep in mind the concept of operator and of expression, which is something that produces a value. And thanks to that, we can then put that value here in this placeholder in the template literal. All right. Now to finish, I just wanted to mention that the ternary operator is not thought as a replacement of if-else statements. Okay, we still need if-else all the time. For example, when we have bigger blocks of code that we need to execute based on a condition. In that case, the ternary operator is not going to work. But the ternary operator is perfect when we just need to take a quick decision, for example, like this one. And that's especially true in places where JavaScript really expects an expression, just like here in this template literal. So here we could not use an if-else statement, and so the ternary operator really comes to our rescue here. So I think you can understand that this one is really, really important, so make sure that you absolutely understand how it works. And once you do understand, then let's move on to the final lecture of this section, which is yet another coding challenge for you to see if you did actually understand how the conditional or ternary operator works. Okay, so I hope you successfully did that. And so let's try to solve it now together. Or actually, let me show you my solution so that you can see how it compares with yours. And as always, you can also find my solution in the final folder in the GitHub repository. Okay? Now, actually, let's start with the bill variable, which I'm going to set to 275, which is here the first test value. And now the tip, and let's calculate it using the ternary operator. So let's implement this rule, which is if the value is between 50 and 300, then the tip should be 15% of the bill value. So that means that bill must be less or equal 300, and at the same time, bill must be greater or equal than 50, right? And again, that's what it means for the bill value to be between 300 and 50. It's going to be less or equal 300 and at the same time greater or equal than 50. So 40, for example, is of course less than 300, but it's also less than 50. And so this part here will then be false. And so this entire expression here, which is then true and false, will be false as well, right? So in this case, the tip here will be the bill value times 15%, which, as I explained here, all we need to do is to multiply it by 15 divided by 100. So that's 0.15. And else, it's 20%. So bill times 0.2. Give it a save, and that's actually it. So that's number 1. And now as number 2, let's log this string to the console as is requested here in number 2. So let's actually grab this template here. So then we just have to replace the values. And so since we're building a string, we are again relying on the template literal. So here we're going to put the bill value. Here we're going to put the tip. And we're missing the curly braces. And here the total value is going to be the bill plus the tip. So we can, as you already know, write an expression here using this operator, so the plus operator. And that's actually it. So let's try it. And with this bill value, the output should actually be exactly like it's written up there. And it is. So 275, the tip is 41.25, so just like here, and the total value is 316.25. Great. And just to understand this one, so this condition a little bit better, let's just take this one and paste it here into the console. And so we see that this one is true. And of course, that's because 275 is less than 300 and more than 50. So it is between this range. And therefore, this part of the ternary operator here will be executed and become the result of this operator, essentially, right? So the result of this operator will be bill times 0.15, and that's the value that will then be assigned to the tip variable, okay? Now let's try another one, so 40. And now the tip was 8. Let's try this one here again. And now the condition is false. So remember that here in the console, we have access to all the variables that we have declared here. So if I write bill now, you will see that it's actually 40. So bill is obviously below 300, but it's also below 50. So this part is false, and true and false gives false. And so in this case, the value that's going to be assigned to tip is 40 times 0.2. And that's exactly 8. So it's what we see here. Okay, and now just for the sake of completion, let's do the last one as well. And yeah, this should have worked as well, because now this one is false again. And that's because this time 430 is above 300. And so 86 should be 430 times 0.2. Let's quickly check that, 0.2, and that's right. That's the 86 that we have up here. Great. So hopefully you did this, and once more, if you did it a little bit differently, that's not a problem at all. I just hope that you made it work, okay? And actually this concludes the coding part of this section. There's just one more lecture left, which is going to be a deeper dive into JavaScript versions, especially into ES5 and ES6. So it's actually into ES5 and ES6. So it's going to be an interesting one, and yeah, I'm waiting for you there. Now that you're familiar with the fundamentals of the JavaScript language, we need to talk about JavaScript releases or versions before moving on. And we briefly talked about this in the intro video, but now let's go into more depth because it's really important to know about how JavaScript releases work and how we can use them. It's important for your work as a web developer, and also because you will see these topics coming up in the developer community all the time. And so you want to be able to understand what's going on. And the best way to start understanding JavaScript versions is by looking at the history of JavaScript. So let's do that. And let's start at the beginning of the internet itself. So quickly after the internet was invented and the first web browsers were developed, developers wanted to start making websites more interactive. In other words, they needed a programming language for the browser. So in 1995, the Netscape Navigator, which by the time was the dominant browser, hired a guy named Brendan Eich to create the very first version of JavaScript in just 10 days. It was called Mocha, so not JavaScript yet, but it already had many of the fundamental features that modern JavaScript has today. So that's very impressive that he basically created this first version in really just 10 days. Then in 1996, Mocha was renamed to LiveScript, which was then again renamed to JavaScript for one simple reason: to attract developers from the hottest language at the time, which was Java. So the Java in JavaScript was really just for marketing reasons, because the language itself has basically nothing to do with Java. Now, some beginners think that this is the case, but actually no. JavaScript and Java are two completely different languages. Also in 1996, Microsoft launched the Internet Explorer, which basically copied JavaScript from Netscape. But they called it JScript for legal reasons because, well, you actually cannot just go around and copy other people's programming languages. Now, what this means is that we now had two very similar but competing languages, which of course is never a good idea in the long run. And so, with the internet growing like crazy around this time, people realized they needed to standardize JavaScript. So the language was submitted to an independent standard organization called ECMA, which in 1997 released ECMAScript 1 or ES1. This was the very first official standard for the JavaScript language. And with this, every browser could now implement the same standard JavaScript. In the real world, we usually use the term ECMAScript to refer to the standard, while JavaScript is used when we talk about the language in practice, as it's implemented in browsers. Now, fast forward to 2009, after a lot of complications and disagreements about where the language should be headed, ES5 was released with a lot of great new features. And then finally, another 6 years later, the much-awaited new version ES6 was launched in June 2015. And this was the single biggest update to the language ever. So it contained a ton of new exciting features, which we will explore throughout this entire course. This was and still is a really big deal for JavaScript and for the whole web developer community. Now, you will also see ES6 being called ES 2015, which is actually the official name, but most people just call it ES6. And so that's what I'm going to do here as well. And actually the reason for ES6 being called ES 2015 officially is that in 2015, ECMAScript changed to an annual release cycle. So right now, there's going to be a new release every single year. The reason for that is that they prefer to just add a small number of new features per year instead of shipping a huge new version every couple of years like it happened with ES6. And so this way, it's going to be much easier for everyone to keep up to date. And so according to this new annual release cycle, in 2016, ES 2016 or ES7 was released, ES 2017 in 2017, and like this, it will continue until the end of time, or something like that. Now, there is one particularity about JavaScript releases which is pretty unique for any programming language, and that is backwards compatibility all the way to ES1. So what does that actually mean? Well, basically it means that if you were to take some JavaScript code written back in 1997 and put it in a modern browser with a modern JavaScript engine today, it would still work just the same. So again, the JavaScript engine that's in our browsers today is able to understand old code written 25 years ago without having to rely on version numbers or anything like that. It just works. And it works this way because of the fundamental principle that's baked into the JavaScript language and its development, which is to not break the web. This means that there is almost never anything removed from the language, but only added in new versions. And actually, we cannot really call them new versions even, because they do not contain breaking changes like when other languages move to a new version. Instead, new versions are always just incremental updates which add new stuff. And so I like to call them releases and not versions. The ECMAScript committee who works on updating the language does all this so that old websites basically keep working forever. Just imagine they removed some important feature that made a website from 2008 work just fine. If you then wanted to visit that page, it would be broken. And that's why we, fortunately, have the don't break the web principle. Now, of course, this comes with problems, because there are tons of old bugs and weird things in the language. Remember that Brendan Eich made the very first version in just 10 days. And no one back then could even imagine what JavaScript would be used for one day. The initial goal of JavaScript was just to add some simple dynamics to pages, not to write whole web applications in the browser like we do today. But anyway, these bugs and weird quirks in the language have been giving the language a bad reputation among many programmers, who can't really take JavaScript serious because of this. But here's the thing. We can actually go around many of this weird stuff by simply learning the modern JavaScript that matters today and just ignore most of the old weird stuff. And so that's exactly what we're going to do in this course. So next time your friends start hating on JavaScript, and believe me, this actually happens, then just tell them about the amazing things that you can build with it. Okay, but now there is one more thing that we need to talk about here, and that is forwards compatibility. So what do you think would happen if we took this totally made up code from the year 2089 and tried to run it in today's browsers? Well, you're probably right, it would not work at all. There would be errors left and right, and nothing would work. That's why we say that JavaScript is not forwards compatible. Basically because current browsers do not understand code from the future. And this actually brings us to our next topic, which is how can we use modern JavaScript today? Because browsers that users are using might be old, and there is no forwards compatibility, right? So to answer the question how we can use modern JavaScript today, we need to consider two distinct scenarios: development and production. So the development phase is simply when you're building the site or application on your computer. To ensure you can use the latest JavaScript features in this phase, all you have to do is to use the most up-to-date version of the Google Chrome browser. This will then ensure that all the features I show you in this course will work for you as well. The second scenario is production, which is when your web application is finished, you deploy it on the internet, and it's then running in your users' browsers. And this is where problems might appear, because this is the part that we actually can't control. We cannot control which browser the user uses, and we also can't assume that all our users always use the latest browsers, right? Now, the solution to this problem is to basically convert these modern JavaScript versions back to ES5 using a process called transpiling and also polyfilling. We will use a tool called Babel later in the course to transpile our code, but for now, during the course, we won't need that. Again, because you're using the most up-to-date browser during development. Transpiling back to ES5 is only necessary after your app is developed and you want to ship it to your users. Alright, so now let's take a look at how different JavaScript releases can be used today. So first off, ES5 is of course fully supported in all browsers today, all the way down to Internet Explorer 9 from 2011. So we can assume that ES5 is safe to be used at this point, which is the reason why we use it as a target for transpiling. Now about the newer releases ES6, ES7 and all the way to ES 2020, as of mid-2020, they are actually quite well supported already in all modern browsers. And we usually call all the current versions together ES6 Plus. So right now that's from ES6 to ES 2020, and basically all together they are the modern JavaScript. Now it's in this modern JavaScript, so in this ES6 Plus, where transpiling comes in, as I mentioned earlier. Again, because it's not safe to assume that all our users are using these modern browsers, and we don't want to break our app for them, right? And by the way, if you want to stay up to date with what features are currently supported in which browser, you can check out the ES6 compatibility table. It's really interesting. The link is actually on my resources page on jonas.io. Next, there are also the future releases of the language, like ES 2021, ES 2022, and so on. And these future releases together are many times called ES Next. Now, why is this even relevant? Well, because most browsers actually start implementing new features even before they enter the official ECMAScript specification. That's possible because as new features are proposed, they have to go through 4 stages, starting with stage 1, where they are first submitted, all the way to stage 4, at which point they enter the language officially. But when a feature is at stage 3, browsers can be pretty sure it will eventually pass to stage 4, and so they're going to start implementing that feature while still in stage 3. And there is a lot more to be said about this, and actually I find this really fascinating, but I'm going to stop here. You can find tons of information about this online if you want to learn more. And a great place to start is actually, once more, this compatibility table that's up here on the slide. But anyway, as these new features start coming out, I will simply add new videos about them to the course in order to keep it updated. With the annual release cycle, this is now way easier to do, because there will be no drastic changes to the language like ES6 was. Okay, and now to finish, let's quickly talk about how versions, or releases, are taught in this course. So, as I said earlier, I will teach you modern JavaScript right from the beginning of the course. Now, I used to teach this course starting with ES5 and then moving to ES6 in the middle of the course. But now, after a couple of years, it was time to fully move to modern JavaScript. However, it's also super important to learn how some things used to be done before we had this fancy modern JavaScript. For example, in this section, I already showed you the modern const and let for variable declarations, but also how we used to use var before. And there will be many more examples like this. But why bother with ES5 at all, you might ask? Well, here is why. First, you will better understand how some features in JavaScript actually work behind the scenes. For example, ES6 classes, which hide all the implementation details of object-oriented programming in JavaScript. Also, many tutorials and example code that you will find online are still written in ES5 today. Plus, as a developer, in many jobs, you will actually have to work on older code bases. And it's totally possible that that code base might still contain a lot of ES5 code. Okay, so I hope that made sense. And that's it for this lecture and for this section. So see you in the next one.